let's talk about slopes of linear functions. A function is increasing if its graph moves upward from left to right. Okay, so this I'm sure you've seen before. The input, the output, when you draw the graph, that is the set of all points that satisfy that rule, if that line is increasing, then we call it an increasing function. Okay? This is a linear function insofar as it has a constant slope throughout all values of x. Okay. You could formally define an increasing function f of x such that for any two x's, for any x1 that's greater than x2, f of x1 is also greater than f of x2. Okay. Similarly, you could define a decreasing function in the same way. You'd simply reverse the inequality. Function is decreasing if for any x1 greater than x2, f of x1 is less than f of x2. Okay, so as you increase x, f of x goes down. So this is a very common problem, obviously, in science or in policy. You're often looking at variables to try to determine whether they have, whether the function that relates those two variables is increasing or decreasing. Okay? While this seems very simple, in reality, what you'll be doing, and we'll see this two sessions from now, is that you will observe phenomena. For example, X might be investment in education by locale, per capita, let's say, and this might be test score outcomes. And you'll observe lots of paired variables, and you might plot them on a graph, and you might want to figure out whether it has an increasing slope or a decreasing slope, or has no slope at all. And that's precisely what ordinary least squares regression is all about, right? Okay. So what's a linear function? It's one where the graph is a straight line. In other words, its slope is constant. How do I write down the equation of a linear function? This you must all remember. You may have different letters that you assign to it. That is, the function might be equal to b plus mx. So y equals b plus mx is the way I learned it. But you may have seen y equals bx plus c or something like that. Okay. The quantity that multiplies the input variable is the slope coefficient, and the quantity that is on its own is the constant term, also known as the y-intercept. Okay? Let's just draw a quick form. In the Cartesian plane, if I were to draw this as the straight line, what quantity is this? B, right? That's the y-intercept. Okay, and if you don't remember that, just keep in mind that the y-intercept is, of course, the point at which x is equal to 0, anytime you're on the y-intercept, x is equal to 0, so you would substitute 0 in here, and so y would be equal to b. What about this point here? What about this distance here, sorry? This is, so you're absolutely right, this is the x-intercept, and what is the quantity that I'm looking for? So you'll have to do a little bit of algebra. Okay, so let's just take a step to do that. Okay, so let's do that a little bit more slowly. Y is equal to mx plus b. This holds everywhere on the line. We are looking for a point on the x-intercept, which means the y value is, of course, equal to 0. So we are looking for the point, the subset of all these points where y itself is equal to 0. So we want the value of x where y is equal to 0. So that's mx. So x is equal to minus b over m. Okay? Okay, so just keep that in mind, and I think that's exactly what we just did. Okay? Okay, now the slope, of course, is also known as the rise over the run. You'll find this very useful on Thursday when we start talking about calculus. For linear functions, the slope is a simple concept. It's a fixed number. The coefficient of x, in this case m, it indicates two things, both steepness and direction, right? So if the slope m is a large number, has large magnitude, then it is a very steep function. Okay, so you could think of it in terms of grade. This is a very steep function, that is, m is very large. This is a relatively shallow function. M is relatively small, so m low, m high. This is a very steep function with a negative m, so this would be minus mh, and this would be minus ml. Okay, a relatively shallow declining function. Okay. We use the concept of slope to define linear functions as opposed to nonlinear functions. Any function that has a constant slope is a linear function. Any function whose slope changes for different values of x is a nonlinear function. Okay? So this is a nonlinear function. Here it is steeply downward sloping. Here it's gradually downward sloping. Here it's flat. Here it's steeply upward sloping. So its slope changes. It is a nonlinear function. So let's talk about equations of those linear functions. We'll stay in the world of linear functions for a little while. Suppose you know only the slope of a linear function. Can you derive its equation? I have a bad habit of asking questions and putting the answers on the board. Actually, in the economics class, you are required to sign up for a class where you're going to be on the hot seat, and you have to answer questions on the readings for that class and to everybody else. But often the questions I ask, the answers are on the board. But sometimes people are so stunned that they're asked that they still don't answer. Okay, so of course the slope, if you just know the slope of a linear function, you cannot construct its equation. Why?
Because you don't know where on the
Yes, Richard.
Why not? Because if you know the slope, I do understand that you put the correct answer up there, but that you know you can describe any 2 points along the line, and it's a straight line. So
Okay.
why can't you derive the equation?
Okay, so that's a good question. If you know the slope, and let's say as a result you know 2 points on the line, why could you not know the equation? Is there a flaw in what I just said? What's the flaw? You don't know 2 points on the line because you know the slope, right? And let's take a look at the picture. Okay, so suppose, Richard, you tell me that the slope is equal to 1. Okay, that means it has a 45-degree angle to the origin. That means that I know that m is equal to 1. Right. So I know the class of equations that it falls into, but not the exact one. Okay? But it's a good question because you see, econometrics and statistics in general is about establishing lines from unknown information. And there are often times when you know only the slope. It shouldn't paralyze you. Knowing the slope still means you know quite a lot. Okay? For example, you know you don't know the equation of that line, but you know the equation to one unknown, that is the constant. Okay? So there are some things that even this will tell you. For example, this tells you, that is knowing that your functional relationship is described by any one of these 3 lines, tells you that if you were to increase x by a certain amount, you would know what the likely impact on y would be. That's the very definition of slope, right? The rise over the run. So knowing the slope and not knowing the intercept might still tell you a lot about a relationship. So get used to this type of questioning that Richard just did, because it should allow you to engage with your exact level of knowledge without without shutting you down or without silencing you if you don't have everything that the cookbook recipe needed you to have. Okay? Now, if you only know the y-intercept of a linear function, again, you would not be able to give me the equation, and the picture is going to be a little bit different. Okay. Okay, can someone tell me, if you know the y-intercept of a linear function, so that means I know b, but I don't know m. So suppose that b is here. So I know that it crosses here. What are some of the different lines that would satisfy that? Sorry, what's your name? Monica. A whole wheel of potential lines, right? So it might look like that. Sorry, my drawing is terrible here. Okay, so any of these. So actually, what's very interesting is that what character is your knowledge if you just know the y-intercept? It's of a much poorer character than if you just knew the slope. Because if you're trying to look at the relationship between x and y, knowing the slope can actually tell you quite a bit. And in fact, it's quite routine in statistical analysis to not know what the intercept is, but to know just the slope. But not knowing the slope means you virtually know nothing, because it's highly unlikely that you're going to be interested in the one case where x is equal to 0. And that's all you can talk about if you just know the y-intercept, right? Okay. Okay, now, so in order to derive the equation, either you have to know both the slope and the y-intercept, or, as Richard pointed out, if you knew 2 points on the line, you could construct the slope, and you could also construct the y-intercept. Okay, and so let's do a problem like that. Okay, so we have to find the equation of the line, which has a slope of 4 and a set of coordinates 3 minus 2, right? And I'd like to try to do that graphically initially so that you get a sense of the intuition, and then we'll look at how that's done algebraically. Okay? Okay. So I think this is the Greek way of solving the problem, that is geometrically, and then we'll do it the Arab way of solving the problem, which is algebraically. Okay, so it has a slope of 4, so we know that it is a relatively steep slope, could be any one of these lines, and we know that one of the points on the line is 3 minus 2. Okay? 3 minus 2 is something like that. Okay, so let's say this is 3 and this is 2. Okay? So we're really looking for a line like this. So I know that this is 3 minus 2. Useful piece of information would be to know what B is, right? B is probably down here. So how might I find out that B from this? Yes, what's your name? Sarah. Okay. That's just from. So let's go. Let's just get used to that. It's something you should internalize. Okay. I don't know if this is going to stay up. Okay. The slope is the rise over the run. So suppose that the rise is equal to the run. The slope would then be 1 over 1, which is 1, and so that would have a 45-degree angle, and here the slope is equal to 1. If the slope was 1 in 10, the rise was 1 for every run of 10, you'd only have a small rise for a long run, so this would be the slope. So here the slope is 1 in 10. Similarly, a slope of 4 would mean a rise of 4 for a run of, you see, so that's why it would look like that. Okay? Okay. So we're looking for this intercept. I know the slope is 4. I know this point is 3. So how would I find out this point? Just thinking geometrically. Yes.
So it would be 3 times 4, which is 12, so you'd be down 12, but you're already down 2, so now you're at 14, negative 14.
Perfect. Okay. Everybody see that?
Yeah.
Okay, she's a fast thinker.
I'm sorry, it's rise over run, so you're at 3 and then negative 2. Now what you want to do, if you're looking for the y-intercept, what that means is that you need to get your x to 0. So your x is at 3. So what you're going to do is you're going to count back. So that's 3 back. So now you're 3 back, but your slope is 4. So you're going to go 4 times 3. And then that's 12. Now you're going down. So it's 12 down, but you're already at negative 2. So it's going to be 12. You're going to go down 12 from negative 2. That gets you to negative 14.
So graphically, it's very helpful, and in certain kinds of, well, pretty much in all sorts of problems, it's always helpful to understand the equations graphically, okay, and to know where you are. Okay, so I know that this point, the y-intercept is minus 14, 0. I know the slope. I'm sorry, 0 minus 14. So b is actually minus 14. So I know that y is equal to mx plus b, which is 4x minus 14. And you could do a quick check to see if this point would make sense. 3 times 4 is 12, minus 14 is minus 2. Okay? Okay, so, and presumably that's what we did. Okay, this is the algebraic way of doing it, which is really just the expression of what we did. Okay, so we know that the equation follows this form, mx plus b. We know that m is 4. We're looking for b. And we let this point, 3 minus 2, be x1, y1. And then we know that x1, y1 is on the line. We let the y-intercept be x2, y2, which is the point here. We're trying to look for that point. Okay. We use the fact that the rise over the run is 4. That's the rise over the run. The change in x is in the denominator. The change in y is in the numerator. And we simply solve for x1. We know that x2 is 0 because we're on the intercept. Okay, and then we solve. Okay. So algebra, this is algebra. Of course, algebra comes from an Arabic word which means completion. Is about the process of looking for an unknown. Okay. And so there's always an unknown in algebra, which you're trying to find. Okay, in this case, the unknown that we completed was the minus 14. Okay. Okay, so here's another problem. Find the equation of the line which passes through now 2 points. So here we have a problem like the one Richard suggested. We have 2 points. We don't know the slope, but of course anytime you have 2 points, you can find the slope, right? There was a long time ago, there still is a restaurant on Amsterdam called Amsterdam Cafe. It's been much renovated since I used to go there as an undergrad, but there was a very mathematical waiter there. That's the sort of thing you find in New York, right? Mathematical waiters and architect taxi drivers. And so at some point, I think a friend of mine and I went in and we had one drink, and we were debating whether to have another one or not, and the guy showed up, the waiter came by and he said, well, if you have one drink, it's a point, but if you have 2 drinks, it's a line. So, so there was a way to sell another drink. And once you've had 2, you can have an infinite number of drinks and not feel bad about it. Okay, so now, so let's find the slope here. Minus 2, 3, and 3, 8. So let's, so I haven't quite drawn this right. Okay. Okay, so I simply want to construct the slope, and of course it's going to be the rise over the run, and at this point you're all experts at this, of course. So what's the rise? It's the change in y, so 8 minus 3, right? And what's the run? Is 5, right? Everybody okay? Okay, so that's m. And you could certainly just work out what this is to get b. Okay. Okay, so yeah, this